Thank you very much. Next, we'll hear from Suresh Raman. Suresh has been at Intuit for 6 years and is currently Director of Product Management. His talk is called Leaning into the Data Mesh, and he'll walk us through Intuit's journey as part of the data platform group, how they're approaching the application of data mesh principles, some early successes, some challenges along the way, and practical considerations they've discovered to help themselves and potentially others on their journey towards this vision of data mesh. Suresh.
Hello all. Hi. Good morning, good afternoon, good evening, wherever you are. Thank you for that introduction. This is very exciting. A big thank you to the folks at Thoughtworks for organizing this, getting us all together, and for the opportunity for us to share our story and our thinking. I'm really looking forward to hearing what other presenters and participants share in their data journeys. And I'm hoping we can learn from each other and build on each other's ideas. Today, I'm going to be talking about Intuit, our data journey, and how we're approaching the data mesh. Before I get into the data mesh part of the discussion, I'd love to share a little bit about how critical and strategic data and AI is to everything we do today at Intuit, and how we're using this to improve our customers' lives. Our mission at Intuit is to power prosperity, and our strategy is to become an AI-driven expert platform. Our goal is to use AI and data to put more money in our customers' pockets, eliminate friction, and deliver confidence every step of the way. So here are some examples of how we use AI in our products to enable these outcomes for our customers. Timely payments for their products and services are the lifeblood of every small business. Delays in payments create potential cash flow problems, and instances of fraud affects their bottom line. We use AI to solve both by determining which payments should be trusted and approving them right away. QuickBooks customers routinely upload and categorize their business expenses. Now, manual methods of uploading receipts and categorizing them takes time and are prone to errors. We use AI to extract and categorize these receipts with instant results on millions of receipts, bills, checks, and bank payments. When customers use our products, they need to enter long bank account numbers, routing numbers. These entries are prone to typos and errors, resulting in delayed refunds and rejected transactions. We use AI to validate these accounts, giving our customers full confidence in their refunds. So these are only some of the examples of how we leverage data, analytics, and AI to improve our customer experiences. There are many more examples where we have leveraged analytics and AI to improve our customer journey, eliminate friction in our products. We see applications of machine learning to drive internal productivity gains for our teams within Intuit. So how do you get to these outcomes sustainably and at scale? How do you get to rinse and repeat? Great AI and analytics needs great data. Great data needs a great set of tools and experiences to produce and consume high quality data. And so let's talk about Intuit's journey into the data mesh. We'll review a brief history of data infrastructure to put that in context, to talk about where we are, how we got here, and why the data mesh is about technology, organization, and culture change. So in the early days of analytics, before there was ETL or big data, there was a database admin, and an analyst. The analyst was borrowing time on the database. Queries were executed at off hours to not stress the database. These were mostly reports for financial reporting on a monthly basis. And so the database admins were the landlords and the analysts were the tenant. And the raw data in the database was a projection of the business events. But the analyst did a great job, generated insightful and impactful analytics. And now the business needed more reports, more data, more analytics. So this required more data, more compute, more time on the database, and this did not scale. So the analysts got their own database. Initially, this was just a copy. This became more specialized, like MPPs. And so now we got weekly reports, daily analytics, and we also got ETL, the data warehouse, and BI. But we also got the great chasm between operational and analytics environments. Moving on, some innovations later, we got the cloud. We got exploding data volumes, but we got distributed compute to handle the exploding data volumes. But now we can decouple storage and compute. Data scientists are here. We are doing more scale, bigger jobs. We can do hourly analytics. We can do analytics on low latency streams of data. But fundamentally, it's the same raw data that's being exchanged, and the chasm just widens. And so now we need data engineers and a data platform team. At Intuit, we migrated our data infrastructure to the cloud in 2019. We've made tremendous progress and innovations in various aspects of our data infrastructure. We've reduced operational incidents by more than 50%. Our ML platform has reduced model deployment times by 99%. And we have seen a 20x growth in model deployments. Our CDC ingestion and Kafka infrastructures have steadily matured to handle larger data volumes, more data types. Our SLAs are tighter. We have built managed stream and batch processing capabilities, curation products to accelerate the data development lifecycle. However, after all these advancements, things are still messy and clunky. We filled the chasm with a data platform team. They manage the ETL pipes from the source to the lake. There are improvements to availability, automation, discoverability, and quality. But business context is missing. The data platform team does not have any context about the data. They always point to the source team. And any questions about the data, about how to use the data, about the compliance of the data requires a three-step dance between the consumer, the producer, and the data platform engineer who are sitting in between. They're trying to glue the conversation. So all this context lives in Jira and Slack messages. Meanwhile, the data keeps getting moved, copied, enriched, reused, abandoned, and the chasm just widens. So this is not a scalable model. Like, we have great tech, we have great automation, and we are still not able to scale. And so what does this look like? What does this look like for our users, the consumers and the producers of data? For data consumers, this is about how do you discover data about a product or a service, not just about a data set or data element. How do you get access to data? If the data is in batch and streaming, what's the lineage? What's the schema of the data? What are the partition keys? And what's the SLA? So you start to see themes of discovery, access, documentation, understanding, and trust. For producers, and in many cases, these are consumers themselves that are producing enrichments on raw data. The concerns are around, how do I document and describe my data? How do I build and operate complex pipelines? How do I stay compliant? How much does all this cost? Will I get alerted and notified if something breaks? So you start to see themes of authoring, deployment, documentation, operations compliance, and cost. Now, when the data mesh paper was published in 2019, this deeply resonated with all the problems we were seeing on the ground and still do. And that paper has inspired us to adopt the data mesh paradigm for our strategy. Thinking of data as a product is a powerful idea. We see this paradigm as a way to drive the culture shift to think of data as a product, just like web or mobile applications or service API. Teams that build applications, produce data, have the best business context on what changed and how. However, ownership cannot happen without a rich suite of tools and services to manage this data lifecycle that abstracts away technology, automates regular tasks, registers all the metadata, and reduces the need to develop new skill sets. And this leads into our strategy, into how we're leaning into the data mesh. Our vision is to enable teams at Intuit to produce and consume high quality data. This in turn allows data teams to be more focused on the Intuit customer problems and leverage high quality data to deliver great analytics and AI-driven outcomes for our customers. And so our approach is to deliver on this vision through 4 different themes: a rich suite of self-serve products that enable business teams to author and deploy and manage data products. These capabilities make it easy to author, manage, operate high quality data. They also capture valuable metadata that in turn power data consumption experiences. A systematic approach to organizing people, code, and data that allows teams to organize around a business problem. And going all in on data ownership through product and program, leveraging self-serve capabilities, evangelizing the need for ownership. And finally, embedding the data with meaning, understanding, business, and context so that the data can be consumed in that context. Now, some of these elements map directly with the data mesh paper, while other ideas are unique to how we're approaching this. So this is a multi-year strategy with ambitious goals. Some of these ideas are still very new, and we are in early stages of ideation and experimentation. While in other areas, we've made some progress and we've had some success as well as learnings. So let's get deeper into each of these ideas. Self-serve products. Now, self-serve data platform capabilities are not a new idea. Self-serve is a good thing, whether or not you're building towards the data mesh. Great self-serve experiences dramatically improve the development lifecycle. And we have seen great examples from vendors, from open source, and companies that have built internal tooling. We think of self-serve capabilities in terms of data processing capabilities used to author data products, and data serving capabilities used to consume the data products. These are fronted by authoring, operational, and discovery and exploration experiences, to name some. And all of these are connected by a single catalog, which we call the metadata registry. At Intuit, we have developed managed capabilities for teams to design and author and deploy their stream and batch pipelines, their ML product models to ingest CDC events from operational stores, provision their operational persistence, curate raw data, and other significant workflows in the data development lifecycle. We also use vendor-provided solutions that come with self-serve interfaces. These self-serve experiences automate the most common, most repetitive day 0, day 1, day 2, and onwards type of tasks to author infrastructure, author code, deploy pipelines, and manage operations. Security and compliance are important considerations for every deployment, and these self-serve capabilities simplify this by building it into the infrastructure. Now, these capabilities also take us one step towards the idea of a data product by integrating the data product being authored with other systems of record and with our metadata registry. So here are some examples of the self-serve experiences we have built at Intuit. This right here is the ML model management console. The user over here can perform a bunch of lifecycle actions related to the lifecycle of an ML model. The user can deploy their model, can update their model, can create new versions, performance test their models to get the optimal infrastructure configuration. They can check for uptime metrics and cost. These capabilities abstract away the need for different technologies used for online model execution and batch execution. These self-serve experiences have enabled a huge acceleration in the time to deploy models, the time to experiment on models, and a massive increase in our model deployment velocity. Now, we have a fairly mature Kafka infrastructure, and these are some of the experiences that enable an engineer or a team of engineers that need to emit events for their near real-time consumption, to create new topics, define their partitioning strategy, establish access policies, and set up multi-region. And on the right, the user can author the event schemas and define the compliance control. We have built our own topic management service that allows different teams at Intuit to easily produce and consume events for near real-time consumption through self-serve. Previously, topic setup was manual and various lifecycle actions could take between 3 to 7 days. Now, this can be done in 15 minutes. Now, this screen is our stream processing platform interface, management interface. Our stream processing platform allows the users to integrate their Git repo, deploy the pipeline into a managed Kubernetes infrastructure. We also use this platform to author features for near real-time and online consumption. On this screen, the user can document their feature spec. Our stream processing platform has unlocked a slew of new real-time use cases across the company, and it's used for a variety of fraud prevention, personalization, marketing, and churn use cases. And this has dramatically brought down SLAs from hours to minutes for analytics consumption. Now, these two screens show the two different ends of a CDC ingestion flow. On the left our persistent service enables application service teams to turn on change eventing from their operational store. And on the right, our batch ETL product enables partitioning while materializing the data, which enables better query performance. Now, these last set of screens show our event authoring experiences that we are building out for authoring tracking plans, but we also see this as potentially being reused for other event authoring use cases. So as you can see, we've made a lot of investments and progress in our self-serve capabilities. These self-serve capabilities have reduced the barrier to entry for authoring data products. This has unlocked new opportunities for teams at Intuit to address customer problems. We have significantly improved some parts of the development process and have reduced what used to take weeks to days, from days to hours, and from hours to minutes. As a result, our teams are able to deploy more, experiment more. We have better SLAs and faster incident resolution times. And our teams can access these self-serve capabilities from the UI directly or programmatically from their notebooks and IDEs. As we think about what's next, our next generation of self-serve capabilities need to be accessible to expert and non-expert users. Our users should be able to construct complex workflows and pipelines across data processing capabilities. We need new self-serve capabilities for schema authoring and lifecycle management, for data modeling. And finally, for data processing, we need config-driven low-code, no-code transformation experiences across stream and batch. These need to be backed by a fleet of background services to monitor quality, reliability, usage, and compliance, which in turn power operational workflows and generates rich metadata signals. We have an opportunity to embed AI and ML into our self-serve flows to reduce the most common manual tasks. This rich metadata that we capture from self-serve experiences and background services, in turn, will power awesome discovery and consumption experiences. Within Intuit, we are in the process of rolling out some really awesome discovery experiences across both batch and streaming locations with quality profiles, change histories, and other rich metadata. We are streamlining how our users can easily get access to data that may live in different hosting locations. Get access to encryption keys. From our follow me homes and user interviews, we see that data discovery and access needs to be embeddable experiences so that these can happen at multiple points in the data lifecycle. And finally, all of this needs to be backed up by the ability to map the data being authored to a team, to the code, the business problem, and the domain, which segues nicely into the next part of our strategy. Organizing people, code, and data. So I have talked about data producers being ultimately responsible for owning and operating their data, and that's also the next part of the strategy. But let's look at this from the data producer's lens and check out some of the frictions our team encountered during the data and ML development lifecycle. So this is not an exhaustive list. Now, any team that's producing a data, a model, a BI dashboard is using a combination of data sources, tools, technologies that cuts across skill sets. As they are constructing their stack for their use case, how do you enable these producer teams to express to the rest of the ecosystem, what is this thing that we are building? What's private? What's externally consumable? If the data can be reused, in what context can be reused? And what is the compliance footprint over here? And how do they do this without getting into Slack conversations and other kinds of manual offline channels? If the data is restricted, how can I request, approve, or deny access for teams that are working on a specific business problem instead of raising multiple tickets to clone individual users' access? So how does a team construct and operate this data product across these variables? Our insight is that in the current state, most teams are aligned around technology. Without the tools to collaborate and manage a shared set of processes and data, this forces a logical business problem to be arbitrarily divided among several teams. And this creates inefficiencies in communication, collaboration, and requires learning new processes. So we see the data product as a way to organize people, code, and data. A data product is a set of internal processes and data that produce a set of external data. The data product exposes a logical model that defines the entities and the relationships for a domain. It is created and managed by a team that understands the business problem as well as the implementation details. Now, this organizing service allows teams to collaborate and construct a data product across stream and batch, across technology stacks to produce whatever your external data product may be, a data set, a dashboard, an ML model, a clickstream tracking plan, other types of artifacts. And this allows the producing team to register the physical infrastructures, their data processes, identify what's internal and external, and map this data product to a domain. So let's see what might a discovery experience for a data product might look like. Now, this wireframe shows a discovery experience for a simple data product, which is just one table. Now, this is a fairly simple representation. We expect more sophisticated representation of a data product with 3, 4, or 5 external services with the ability to browse a domain and so on. So back to this example. Here, the identity table is part of a data product called user profile. Now, the user profile data product has a set of admins which got captured by the data product service. This has rich metadata extracted from the data product service, from the self-serve authoring experiences, as well as all the background services. A consumer can get a bird's eye view of the data product, the ownership, schema, and quality information. And consumers can dig deeper into the schema, into the lineage and relationships with other tables, the change history, and so on. You can see what other data products are dependent on this data product. The change history is a combination of changes in the data as well as code, which is captured through the data product service. And the last tab, resources, captures the hosting infrastructures for this table as well as other parts of the data product. A permissions graph shows the user request access dialog, and if the user does not have access. So now the user can request access from the data product discovery experience. So let's go ahead and make an access request. So now the consumer who's in the act of creating a data product herself can inform the data product owner about the purpose of the access request so that the owner of the identity data product has the context of the access request, not just from what's written up in the description, but also through the formal linkage to the attrition data product. And in this next screen, the user is not just requesting access for herself, but for her team members as well as for the headless role that will be used to execute the production workloads. Now, this screen or this workflow reduces the need for cloning requests for different team members. The team does not need to worry about permissions when getting ready to deploy. And very likely, the team can reuse this non-human user role across the different processes, whether it's batch or stream or different parts of batch. So these are some examples of our and earlier representations of how we think about the data product service. We are still very early in this journey. We anticipate there will be significant learnings and pivots as we roll out this capability, sitting alongside our self-serve data platform products. Moving on to ownership. As I mentioned earlier, we are going all in on ownership. And this is what we mean by ownership. The idea is to bring together the owning team, the scope, and the responsibilities to manage to produce and manage a high quality data product. Now, all of this needs to be enabled via a data product service, via the self-serve capabilities, via quality and monitoring tools across the different places where the data may live. So how do you get started on this, right? This is also the part of the presentation where I talk about people and process. How do you evangelize this? How do you tie this back to business impact and end user benefit? You can go into a corner and build the data product service and come back after a year, but none of our businesses are static. There are existing business operations, critical new requirements, and pressures to add new data sets, new requirements, new patterns for analytics and machine learning. And the business can't wait. So our approach is to start in place, fixing some of the biggest gaps that exist in the data ecosystem today, identify opportunities and impactful use cases to produce high quality data. And we do all this while we are building towards our vision. So our approach to driving ownership is through a combination of product and program. I talked about our managed data platform capabilities that provide self-serve experiences, but we have a lot of legacy and business critical data flows that don't leverage these yet. Keeping this in mind, we've built ownership claiming into our discovery experiences, into our self-serve ingestion pipeline experiences, as well as self-serve batch ETL experiences, so that teams can claim ownership of existing data assets. Last year, when we started analyzing our ownership coverage of data, and we decided to look at who's using the data, we found a lot of unused and orphaned data assets. So we have leveraged observability and usage statistics to eliminate massive amounts of unused data. We've moved away from just capturing email addresses to more durable sources of truth that map a data product to other systems of record like Jira or ServiceNow. We have a curation product that allows data stewards to curate raw tables in the lake to produce high quality domain entities. We are driving ownership claiming and stewardship programs to claim ownership, identify domain owners, and migrate legacy data assets and pipelines to leverage self-serve data platform products. We are still early in our journey of identifying owners for all the data assets, having owning teams operate and manage their data assets. But we made a significant dent by identifying owners for pipelines and data assets in the lake, eliminating a significant amount of unused and abandoned tables and pipelines. This reduces our cost footprint, our management footprint, but more relevant, it reduces the FUD for our data consumers when they encounter massive amounts of data in the lake during the discovery and exploration phase. So through these efforts, we are starting to capture valuable metadata about our data ecosystem, but also improving data quality and impacting the business. As an example, through our curation product, we have mastered deduped customer records to produce high quality customer data, which in turn has produced more relevant, contextual customer data for our customer success teams, which in turn reduces the time spent on support calls and reduces call volumes. Now, these are just some examples. There are many other instances where improvements in our data quality has directly impacted our customer outcomes. Our vision is to have 100% ownership of all data assets and transfer the responsibility of owning these assets through self-serve capabilities. In this paradigm, we believe that the future of data ingestion needs to move away from just copying and replicating data from transactional stores to the data lake, to a model where well-defined, enriched data products are being produced at source using event-driven architectures. This allows the source team that owns this data to embed the data with meaning, relationships, and allows them to approach data sharing with internal teams the same way they approach this in the product experiences. Now, this is a significant shift from how we operate today and will require an extensive set of new capabilities for entity modeling, event schema authoring for our product teams. We've been experimenting our way into this with some POCs and a limited number of use cases. And this is once again, we are very early into our journey here. This last screen grab just shows a shift in mindset, in behavior on the ground. When previously something was not available through self-serve, there was a ticket for the data platform team to go and modify the schema. But now the engineer from the source team is able to do this and is actually, without being prompted, is asking how to do this. So this is the last part of our strategy, and this is where I'm bringing all this together. So putting all this together, our vision of the data mesh is a single system that exists to capture and relate information about data meaning, relationships, operational context, business context, and ownership to enable the collaboration between producers and consumers of data. The three broad categories of information that are required to build a data mesh and enable our vision for teams to operate high quality data are, number one, on the physical plane. The physical plane describes where the data is stored and where processes are executing. This metadata must be collected so that users can locate and connect to these systems to retrieve data or to deploy processes. This information needs to be registered with a central catalog anytime a new process that's producing data gets deployed. Now, for this registration to occur, we need self-serve platform capabilities where processes are being deployed. The second is the operational plane. Now, the operational plane layers on the notion of the data product and its dependency relationships with other data products. Formally capturing this dependency relationship provides an understanding of the operational impacts when changes are made. Now, this information allows teams to operate their data products in a reliable, secure, and governable manner, knowing their upstream and downstream dependencies, having a record of their security and compliance controls. The data product definition, its internal details may be registered with the central catalog, needs to be registered with the central catalog, and then results from monitoring, quality, observability, and change histories all enrich the discovery experiences. And finally, the business plane. The business information further describes the data meaning and relationships to enable better data understanding and context. Now, this is accomplished through a formal entity modeling language that data producers can use to describe their APIs. This modeling language and a process to add new entities to the data ecosystem ensures that data is clean, organized, connected, and discoverable. So when you put all this together, what do you get? You get data that is connected, documented with meaning and context. The data is mapped to the infrastructure, the technology, the team, and the domain. And there are no backdoors needed to create dark data. Background services ensure that data is accurate, fresh, compliant, and timely. And then finally, all of this generates rich metadata, which in turn produce awesome discovery experiences, as well as consumption experiences, and finally experiences for operations. And then when all this starts to happen, you have a data ecosystem where you can start to answer all the questions that we laid out early on for producers and consumers of data. And so this concludes my presentation. Thank you very much for your time and your attention. All this content that I've produced over here, that I've shared with you, is a result of some awesome teamwork from folks within Intuit. We've had some visionary data leaders at Intuit, both past and present, and we have some amazing product design and engineering teams that are building these capabilities. I hope the problem statements and the progress we've made and some of our ideas resonate with your data journeys, with what you're experiencing on the ground and how you're approaching this. I'm really looking forward to keep the conversation going. Again, a big thank you to the folks at Thoughtworks for instigating this movement, for organizing this and getting us together, and for the opportunity to present our work. Thank you very much. Look forward to talking to you again. Thank you.